Hi guys, this is Miss Cairo here. We're on page 165 in your activity book. Please have that open and ready. And also please get your pencil ready as well. So again, there's three methods that we are learning on how to solve division problems. We've been practicing a lot with the digit by digit method. And right now we're going to practice the expanded notation and the place value sections method. And how we're going to do this is I would like you to do the problems that I'm going to do in this video in your book. Nice and small, unfortunately, so that you have examples to refer back to when you're solving problems on your own in future lessons and perhaps maybe some when you're doing homework, okay? So the problem that we're going to solve first is problem number 16. It's 4 goes into 3,183, and we're going to use the expanded notation method. And again, this is going to be done nice and small in your book. Just make sure it's nice and neat, again, so that you can refer back to. I'm going to write it out nice and big so that you guys can easily follow along. 3,183 divided by 4. And with expanded notation, we are going to be showing the zeros and the multipliers quite a bit, and I'll walk you through. This is similar, yet a little different between comparing it to the digit by digit method. Okay, so first things first, we're looking at our divisor of 4, and we're looking at our dividend of 3,183. I still use the underlying method just to kind of keep track of my place values to get us started with. So what I'd like you to do is I'd like you to underline the 3 in the dividend, and that represents 3,000. And we're asking yourself, can we multiply 4 by something thousand to get 3,000? And the answer is no. Okay, so 4 times 1,000 is equal to 4,000. That's too much. So it goes in 0,000 times. So what the teacher did in the other video is that she set it up like with the place values, T for thousands. We're not going to have any partial quotients in our thousands place for this one. So that brings us to our hundreds place value then. We're going to underline the 1 as well. So carry your underline over, and now we have 31 underlined. And again, you're doing this in your book. Do you have 31 underlined? And we're asking ourselves, how many times can 4 go into 3,100, basically? Okay, so I'm thinking in my head, 4 times what will get us something close to, without going over, 3,100. And I'm looking at that 8 and the 3 as if they like really just, I just put zeros there to kind of estimate that there. And we know with our zero property is we can ignore our digits or our zeros in the tens and the ones place for now. And we're thinking to ourselves, how many times can 4 go into 31? 4 times what gets us something close to 31 without going over? Go ahead and try it. And did you get 7? Yeah, 4 times 7 is 28. The next digit up, 4 times 8 is 32. That's too much. So 4 times 7, we're going to have a 7 in our answer in our 100 spot. So in your quotient, above the 1, we're going to put the digit 7 in the 100 spot. And we're going to show the zeros and the multipliers. This, we ignored the 2 zeros, was actually we were aiming for close to 3,100. If we ignored the zeros, we would have 2 zeros here and then 2 zeros in our factors. So 4 times 700 is equal to 2,800, which is, again, close to 3,100 without going over. So here's my tip for you guys. With expanded notation in your quotient, you can only do one digit at a time, and each time you put it, your digit, your non-zero number, we're going to fill in basically our place values with zeros until we reach our last place value in this case, which is our ones. So in the 10 spot, I'm going to put a 0, and in the 1 spot, I'm going to do a 0 all the way to the end. Okay, so now we have 700 as our partial quotient answer. And now we're going to multiply 700. We're going to follow these same steps we just divided. We're going to multiply 700 times 4. I already said it. It's 2,800. 7 times 4 is 28 plus 2 zeros. And this is the tip again I have for you guys. All our place values have to be lined up correctly. 2,800. Make sure all your digits look like mine. They're going underneath 3,183 with all of the place values stacked correctly. Okay, and now we're going to subtract. This involves a little bit of a more longer subtraction than digit by digit. What is 3,183 minus 2,800? Go ahead and try it. Did you get 383? Okay, great job. And now we're starting all over. Again, this doesn't necessarily apply. This was more for digit by digit. There's nothing to bring down. What we're looking at now is how many times does 4 go into 383. And again, we're going to go, just like the process here, I do some underlining. I'm thinking to myself, can 4 go into 3? It can't. Can 4 go into 38? And it can. Here's what we're thinking in our head. 4 times what gets us something close to 380. Do you see how I changed that 3 to a 0? I'm not necessarily concerned with the 3. I'm just concerned with the 3 that's in the hundreds and the 8 that's in the tens. How many times can we multiply 4 by something to get close to 380 without going over? So I'm going to ignore that 0 in the 1 spot. I'm really just looking at the 38 for now. 4 times what gets us something close to 38 without going over? Go ahead and try it. And it's 9. 4 times 9 is 36, and we ignored 1 0. So I'm going to place 1 0 in. We want it to get it close to 380. I put 360, and then 1 0 over here. And now we're working with 4 times 90. So with the expanded notation, we're going to be building upon the 700. We're going to be putting our partial quotients on top. So we have a 9 in the 10 spot in our quotient. And then again, we add zeros. We only do one non-zero at a time. We're going to add a 0 until we get to our last place value, which is the ones. And now we have 90. Next step is to multiply. 90 times 4, I already said it. It's 360. We're going to put 360 underneath 383, and we're going to subtract. Go ahead and try it. Did you get 23? Okay, let's keep going. 4 goes into 23 how many times now? So again, I'm thinking in my head, 4 times what gets me something close to 23 without going over? What is it? It's times 5. Yep. So let me change my color here. 4 times 5 is 20. 4 times 6 is 24. That was too much. So on top of the 90, we're going to put a 5 in our 1 spot. And then we're going to multiply. What's 5 times 4? 20. I'm running out of room. Underneath 23, go ahead and put 20. 23 minus 20 is 3. And that was in our 1 spot. We have no other place values to look at. That is our remainder. 3 is less than 4, so we did a good job with that. Our next step, to get our quotient, we have 790 and 5. We have to add all 3 of these together. These are our partial quotients, and we could do this mentally. 7 is going to be in our 100 spot. 9 is going to be in our tens. 5 is going to be in our ones to make the number 795. Don't forget our remainder. We had something left over. R3 is what we'll write, and we'll circle it. And that should be nice and neat and hopefully small, and hopefully it fit into your book so you can refer back to. That is solving using the expanded notation way.